And good morning, everyone. It's Dr. Chris Roddenberry coming to you live from Willow Springs, 1 mile from the Lowe's grocery store. How's everybody doing this morning? Thanks for coming today. It's good to see everybody. You doing all right? I see we have Emma in the house, Nick Valentino, and Angelina Yang. Hey, I want to thank everybody for coming to the webinar last night. I had a really good attendance. I think we had 26 out of 56 people, which is a pretty high percentage for the live broadcast. And I just want to thank you for coming, and y'all really did a great job participating. Everybody doing well out there this morning? If you're in the audience, go ahead and type me a hello in the chat bar and let me know you're there. I see we already have Emma, Nicholas, and Angelina. Oh, we got Nicole Wong, Wong Nicole. I love your name and how it's backwards, Nicole. That's pretty cool. Y'all doing all right today? We are at the end of week one. Your discussion boards are due tonight. Your week one homework is going to be due tomorrow night. Okay, I just want to let you know about the discussion board grades and extra credit. Usually, discussion boards due on Friday night, on Thursday night. Usually, it takes me till about lunchtime or 2 o'clock on Friday to get your extra credit and all your grades updated. So don't worry if you don't see your extra credit tomorrow morning. If you don't see it by tomorrow night at 10 o'clock, then maybe something is wrong. But I promise I'll get it updated on Friday. So what's up? Tell me something good. Anything to share? Anybody having problems? How's your first week going? Looks like we have 5 people here, which is a pretty good class to start. Okay, we are talking about the second half of chapter 2 today. Oh, we have 6 people now. Hello to whoever the last couple of people are. We're talking about the second half of chapter 1 today. I'm going to be honest with you. Some students don't find the second half of chapter 1 very interesting. We're going to talk about research methods, case studies, experiments, and correlations, things you may or may not have heard of. It's not the most exciting part of psychology, but I promise you, if you can make it through today, we're going to start talking about the brain next week. And I promise you, you will find that exciting and interesting. But we're going to talk about research methods a little bit today. Oh my goodness, the audience has slid up to 7 people now. If you're here and you want to say hello, go ahead and type me a chat hello in the chat bar and let me know how you're doing. If you have any questions during this broadcast, you can type them in the chat bar. I've got my phone right here with the chat, and I can see any problems you may have, and I'd be more than happy to answer any questions you have. Okay. Hi, Miller. Good to see you. Thanks for coming this morning. Okay, so if you'll remember yesterday, I suggested to you on the first slide of the entire class that psychology was different than philosophy because psychology relies on observation and measurement. Philosophers talk about what they think the mind is like, but psychologists actually study, research, and measure their theories to make sure that they are correct. If you think about it, that's what science does. We can make theories about how the world works, but then science is us going back and testing that theory to make sure that what we say is actually correct. So science is all about measurement. Now, science is not a topic. It's not biology. It's not chemistry. It's not psychology. Science is merely a set of tools that allow you to observe the world uh, and correctly and make correct deductions about how the world works. So science is measurement. It's a set of tools. So in the second half of chapter 1, as in all textbooks, what it's going to do, it's going to give you a brief introduction to the ways in which psychologists gather information. Over the course of the semester, I'm going to be talking about different research studies. And just keep in mind that all of the findings, all of the research that's in this book was developed through these methods that I'm going to be talking about today. Okay, So let's go ahead, and get started with the PowerPoint presentation. So we're going to talk about the steps of the scientific process, and then we're going to talk about the three broad categories of making measurements in psychology: descriptive research methods, experiments, and correlations. All right, let's go ahead and get started. Now, the scientific process is a systematic process of developing and testing theories. We use logic, good ideas to develop our theories of why things happen, but we don't stop there. We then go and measure the world to see if our theories are accurate given the data that we can collect. Okay? And so we develop our theories. And then we take our theories and we adjust them based on the data. And then we test them again. And then we uh, adjust our theory. Then we test them again. So science is a process of developing and testing theories. Now, um, if you would, while I'm talking, can somebody, I know you all have heard the definition of what a hypothesis is. I've got one written up here, but can anybody tell me what the definition your teacher told you in 8th grade science class? What's the definition of hypothesis? It's a two-word phrase that my teacher told me in 8th grade. What's that two-word definition of hypothesis, of theory that we all uh, of hypothesis that we all learn? As I wait for the answer, I'm going to go ahead and talk about this slide right here. A theory is an abstract explanation of why something happens. It's not just an observation of something happening, but it's the psychologist's attempt to explain why something happens. Very good, Miller. You are right on target. Nicholas, you're almost there. It's that educated guess. So a theory is an explanation of why something happens. Why do birds fly? Why do apples fall from trees down to the ground? Why do some people become depressed? Any answer to those questions I've just posed is a theory. You can have a theory of anything. I could have a theory of why students come to my class. They come to my class for the extra credit. They come for the knowledge. So a theory is an explanation of why something happens. Here's an example down at the bottom of the screen you see. Low self-esteem is a result of a lack of social interaction. I'm not saying that's true. I'm just saying that's my attempt to explain why people have low self-esteem. You could come up with your own theory about why people have low self-esteem. Maybe it's because their fathers are mean to them. Maybe it's because they don't have a lot of money. Any explanation you could give to tell me why people have low self-esteem is a theory. Now, theories are general and they're abstract and they're hard to measure. But what we do is we take these theories and then we see if we can find a way to measure an example of that theory working in the real world. And so what we do is we develop a hypothesis. Now, Miller is right. Miller says an educated guess. Why do we say educated? Well, it's educated because we have a theory. So we make a guess based upon the theory. Now, the theory may come from us reading about other people's work, or it may be something that we come up with on our own. But a hypothesis is a specific attempt to make a guess about what we should observe if the theory is true. So if I have the theory that low self-esteem is a result of a lack of social interaction, then what I should find is that people with fewer friends have lower self-esteem. So what I do is I go out and I give people a self-esteem questionnaire and I ask them to tell me how many friends they have. If my theory is correct, then what I should see is that people with fewer friends have lower self-esteem than people with a lot of friends, right? And so what we do is we have a theory, which is an explanation for why something happens, and then what we have to do as a scientist is go out and measure a situation that should occur if that theory is true. And so what we're going to do in science is we're going to develop theories about how the brain works, how self-esteem works, how memory works, and then we're going to try to show how it can work in a concrete, measurable situation. So I do want you to know that science is nothing more than a process of developing and testing theories. I develop a theory, I try to show it, demonstrate it in the real world. If I can't demonstrate it in the real world, then I throw my theory away or change it. If I can demonstrate it in the world, then I keep my theory and try to test it again. And so that's in a nutshell what science is. It's coming up with explanations for why you think things happen, and then trying to go out and demonstrate that they really happen in a specific measurable event. All right, now your book's going to have this chart right here and talk about the steps in the research process. And I just want you to be familiar with sort of all the steps in a research process. As I suggested to you, we formulate a theory by consulting the existing literature. You go and read what other scientists have done. That leads you to come up with a theory or an explanation for why the thing you're researching occurs. You then develop a concrete observable test where your theory can fail. You develop a hypothesis, if you will. What we then do is we choose a research method for gathering data. Okay, we go out and do an experiment, right? Then we analyze the data to see if the numbers support our theory. And then the most important thing we do is we share the results by writing an article. Now, why is sharing so important? Well, scientists are building their work and their theories on top of theories that existed before. So it's very important if you discover something, if you prove a theory to be correct, it's important that you tell the rest of the world about your experiment and your theory. And so what we do in science is we formulate and test these theories with experiments and analyze the data, and then we write journal articles so that people know what we did. And if you look in your book, you're going to see these 5 steps in the research process. Okay? And on your exam, I may ask you to tell me what a theory is and what a hypothesis. I'm going to want you to know at least those 2 things. And then I want you to really be aware that it's very important that we share our results once we test our hypotheses. Now, things to keep in mind. If you can't prove that your theory is wrong, then you can't prove that your theory is right. So a theory must be testable. A theory is only good if you can test it and prove it to be wrong. If you can prove it to be wrong, but you don't, then we accept that theory as being true temporarily. But if you can't test that theory, then your theory is garbage in a sense. Now, theories are always temporary. If you discover at some point that your theory is wrong, then you have to change it. A lot of people who don't understand science think that science is silly because they say science will tell you one thing and then science will tell you another thing. That is in fact true. Theories are only good until we prove them false. So theories are not things set in stone. They're not laws. They're not immutable. They in fact are just how we explain a phenomenon at a given point until we find a better explanation. Okay? And remember, sharing your results allows everybody else to know what you did so they don't have to repeat the same experiment. So it's very important that you understand this research process. Now, will we talk about this research process over the course of this semester? Not really, but at some point you may have to take a research methods class, and it will be important that you understand these 5 steps of the research process. All right, now, what the rest of chapter 1 does is it sort of summarizes the 3 broad ways in which scientists, like psychologists, make measurements. So these are just 3 categories of making measurements. And you've got this chart in your textbook, and you'll notice that we have the broad method of descriptive methods, we have correlational methods, and we have experiments. Have any of you ever heard of correlations or experiments? How do you know if a hypothesis is good? That's a great question. If your hypothesis is specific and measurable, Nicholas. You have to have a hypothesis that is specific and measurable. Okay? And your hypothesis has to be disprovable. Okay? So I can measure the number of friends that people have, I can measure their self esteem, and I can show that people have higher self esteem if they have more friends, but I can also show that that's not the truth. Because I can measure these two things and I have a very specific guess about what should happen, that is a good hypothesis. Great question, Nicholas. Very, very good question. Okay. So there are three broad methods for making measurements to test hypotheses. Each of these methods has strengths and each of these methods has weaknesses. What I'm going to do for the rest of this class is I'm going to go over and sort of talk about these different research methods. And then over the course of the semester, when I say scientists in a correlation found this, you'll go, oh, I remember that from chapter 1. When I say this experiment showed this, you'll go, oh, wow, I remember that from chapter 1. So it's very important if you're going to be a scientist that you understand the research, the process of gathering data. Good morning, Ryan. Thanks for joining us. We're talking about the different ways of gathering data. I told the class in the first minute of class that if you looked on slide 1 of yesterday's lecture, Tuesday's lecture, science is a process of measuring things. And so we're talking about how we measure things today. Okay. Now, the first method we're going to talk about are descriptive methods. Now, there are three different types of descriptive methods that your book talks about: observational studies, self-report, and case studies. And the similarity of these three specific types of descriptive methods is that we really are just measuring things. Now, I'm going to talk, I just told you that, but I'm going to show you how correlations and experiments are a little bit more than just measuring things. But sometimes as a scientist, you just go out and observe things happening in the real world. Okay, so what you does is the researcher creates a systematic process for making observations on the behavior of individuals and interests, either in a laboratory setting, so I can bring you into my laboratory and watch you act, or I can go out in the real world and watch you act. You know, one of the most famous developmental psychologists in the world, Jean Piaget, used to go out to children's playgrounds and watch children play. And he had some very interesting theories on what children were thinking about and their intellectual abilities during this period. So he would just go out to playgrounds and watch children play, and he would write down the things that they did. He was simply observing those kids in a natural setting. Now, if he had wanted, he could have brought them into his laboratory and watched them there as well. Now, there are advantages of using laboratory observations or naturalistic observations. In a laboratory, you have a little more control over where your participants go and what they do. All right. The only problem with a laboratory observation is that sometimes when participants know they're being watched, they change their behavior. Do you folks, I'm sure you folks do that. You probably act a certain way, but if you know people are looking at you, you change your behavior because you know people are watching at you. Same thing with observational studies. We can bring people into the lab and watch them, or we can go out in the real world and watch them. And the advantage of going out into the real world is if they don't know we're watching them, they're going to act really, really naturally. If you look over here on this side, I've got a picture of a laboratory observation, one of the most famous ones in psychology. And we're going to talk about it in chapter 4. It's called the strange situation experiment. I shouldn't have wrote that word experiment. It's a strange situation design, really. And what Mary Ainsworth was interested in the bond that children had with their primary caregiver during the first 2 years. And so what she would do is she would bring mothers and their little babies into her laboratory, and she would watch how the babies acted when the mom got up and left the room and then came back into the room. And she just simply watched the children's behavior. And she found that some children were extremely clingy, Some children tended to get mad at the mom when she came back in, and some children seemed to be happy to see the mother. And she developed a theory of attachment based on her doing nothing more than watching how children acted when their mom left the room and came back in. Does anybody know what do children do when mom leaves them alone? When mom leaves the room, what do children typically do? They cry, right? Well, she wanted to see how quickly they stopped crying when the mom came back in. And she found that some children quit crying faster than others. And so she developed a theory of attachment based on this simple observation. Okay? Now, so what we can do is we can go out in the world and observe things. You know, I saw a talk by a public health specialist one time who was interested in hand washing behavior because that's the way you avoid transmitting diseases. And so this person would go out into bathrooms on a college campus and record whether or not people washed their hands and whether or not they used soap. These are simply observational studies. And in observational studies, we'll look at lots of different people to see if our theory is supported. Now, another descriptive method that we're going to talk about quite a bit are case studies. Sometimes psychologists will find one person who maybe has brain damage or has something happen to him that is very unique, and psychologists will study that one person in depth for a long time. And so they do what's known as a case study. And a case study is an in-depth study of usually one individual, N equals one, that has a unique situation. Okay, so for example, here, this picture down here is a fellow who turned out to be a mass murderer. So a psychologist might want to go into prison and study this one person for many years to kind of figure out what made this person commit mass murder. That is what we call a case study. Now, the neat thing about case studies is they let us study unique cases that we couldn't create experimentally. So I can't give you brain damage and study you. But if you get in a car accident and your brain is damaged, I might find you worthwhile to study to see if I can learn about that brain part that is damaged. Now, the disadvantage of the case study is that people are completely unique. And so sometimes it's hard to draw a conclusion when you only measure one person. But case studies are incredibly important and have shown us a lot of, taught us a lot about the brain in psychology. In fact, there's some sort of, what is it? Famous case studies. We're going to talk about this a little later. Jeannie the Wild Child. This was a girl who grew up in California, and her dad locked her in a bedroom for the first 11 years of her life and never spoke to her and never let anybody speak to her. He chained her to a crib and would feed her underneath her door, and he never let her out of her bedroom. When social services found her at the age of 11, she hadn't learned how to speak. And so scientists were interested. They wanted to know, can somebody learn a language at any age? And you know what? It turns out that you can't. Jeannie had missed a critical period for language, and so she was never able to learn how to speak because she hadn't learned how to. And we realize that there's a critical period for language during the first 2 years when you must be exposed to a language and taught it, or you will never learn it. And so Jeannie the Wild Child, if you think about it, we couldn't do that to a person. We couldn't get a baby and isolate them for 11 years. That's incredibly unethical. But if it happens, we can learn something about it. And so Jeannie is a very, very famous case study that demonstrates the critical period for language development. This guy right under here, a fellow named Henry Molaison, had brain surgery because he had really bad seizures that they couldn't fix. And so his brain, doctors went in and removed part of his brain. They moved this part called the hippocampus. You don't need to know that now, but you're going to need to know that in chapter 7, which is a part of your brain, and it made his seizures go away. The only problem was Henry couldn't learn anything new. His memory was completely wrecked, and he was unable to remember anything after that. And so doctors realized that the hippocampus must be important for memory, right? So both of these cases represent really unique events, okay, that allowed us to go in and learn about the brain by studying one person whose situation is completely unique. Does that make sense? Now, here's the other thing. Psychologists, the last descriptive methods that psychologists will use are surveys and self-report measures. Personality tests, self-esteem questionnaires, narcissism questionnaires. Psychologists do create and use a lot of surveys and personality tests to measure people and learn about how they function. If you look underneath me, you'll see there are examples of surveys. There's the Adult Romantic Attachment Scale, which measures how people's run their adult romantic relationships. I'm going to have you folks take a stress inventory later this semester to measure your level of stress. I'm going to have you take the Big Five personality inventory, and we're going to learn about our personalities. And then there's a short test called the BDI, the Beck Depression Inventory, that can be used to discover whether or not you have the symptoms of depression. These are all surveys where we ask people to tell us about themselves, and we learn a little bit about who they are. Now, surveys and questionnaires can be used to gather data from a large number of people. It's cheap, it's easy, and it's quick. Very, very useful for gathering large amounts of data about a large group of people. And so that's the advantage of surveys. The only disadvantage of surveys is that sometimes people can lie. Sometimes people don't think correctly about themselves. You might think you're more extroverted than you really are. You might think you're have a better relationship that you really do. Sometimes people lie or don't answer their surveys correctly. Now, here's the thing. Descriptive methods, so surveys, case studies, and observational studies are three ways of gathering information that we can use to build theories, right? And these are often the easiest ways to gather data. So you could go out today and hand out a personality questionnaire to 100 people yourself. That quick and that easy. You could find an interesting person and study them for a year, and that would be kind of easy to do too. Or you could go out to a parking deck or a bathroom and observe people's behavior and gather data. So these are really, really easy ways to gather data and learn about people. However, there are some limitations with these methods. The limitation with descriptive methods is that we don't measure how one variable affects another. So in Mary Ainsworth's attachment study, she can tell you that there are three different ways that children respond to their mom when their mom leaves them and comes back in the room. She has three attachment styles. But what Mary Ainsworth can't tell you is what caused those children to develop that attachment style. She just can tell you that descriptively there tend to be three kinds of children: normal children, clingy children, and avoidant children. But that leaves the question, why did those children develop those personalities? She can't tell because she was only using a descriptive study. Okay? Now, the gold standard for doing research is what we call an experiment. And in an experiment, we demonstrate a causal relationship between two variables. Now, the disadvantage of an experiment is that it's very difficult to set up, and it requires that the experimenter set up a situation which sometimes is not realistic. okay? So you have to have a lot of control and you have to bring the participant into the lab. And so it's hard to, sometimes experiments aren't that realistic. But the advantage, the huge advantage of an experiment is that you can demonstrate that one variable causes another variable, okay? One variable causes another variable, okay? So experiments allow us to demonstrate cause. If you really understand something, you know the causal link. If I understand gravity, then I can tell you what will happen when I let go of an apple from 4 feet. Gravity is going to pull it to the ground. I know that because I understand the causal direction. So what we want to do in psychology is we want to demonstrate that we know that one variable causes another variable. Okay? Now, how do we do an experiment? What we do is we get a group of people, a sample of people, okay? And let's see, what page is that? That is my screen share. Okay, so what we're going to do is we're going to get a sample of people. And then what I'm going to do is I'm going to randomly select into two groups. Group A and Group B. All right. Now, if I randomly select people, so I'm going to take 10 people, and what I'm going to do is I'm going to have them pick numbers, pick pieces of paper out of a hat. And so if I have 10 people, five of my pieces of paper will say Group A, and five of my pieces of paper will say Group B. And so what I'll do is I'll let these people pick out of a hat. And if I do that, I'm going to get two groups that are probably similar to one another. Let's say we have 9 students here in class today. If I had you folks, if we were in a classroom and I had you pick pieces of paper out of a hat that said either Group A or Group B, and then I compared the average height of these two groups, chances are these two groups would be similar in average height. Probably these two groups would be similar in weight. Probably these two groups will be similar in the average level of self-esteem that they have. So what I do is I use random assignment. Random assignment. Random assignment to create two groups. Now, this does a very, very important thing. What this does is this creates two groups that are similar to one another. And if you look in the bottom square of this chart right here, you're going to see that we have this thing called the independent variable, and we have a control group and an experimental group. Those represent control group, could represent group A, and the experimental group is group B. Now, because I've randomly assigned these people to these two groups, at the beginning of my study, I'm pretty sure that they are similar to one another, okay? What I'm then going to do is I'm going to create a situation where I alter their situation by one factor. What I'm going to do is I'm going to manipulate an independent variable, right? So we might say that getting negative feedback hurts your self-esteem, okay? So what I do is I have these two groups, a control group and an experimental group. And I might make them do a task like write a poem, okay? And after they write a poem, what I'm going to do is I'm going to tell the control group, that's a good poem. I'm going to tell the experimental group, oh, your poem sucked. Your poem was absolutely horrible. So the independent variable is whether or not I told you that your poem was terrible. And we have two groups of people, probably with the same level of confidence and self-esteem, but one of these groups has been told that their poem is terrible, and the people in the other group have been told that their poem is good. And then what I'm going to do is I'm going to quickly measure their self-esteem, which is the dependent variable. all right? And then what we'll see is I will see if their levels of self-esteem, the average level of self-esteem is different between the two groups. And if it is, then the only difference between these two groups is the feedback I gave them. So what I can conclude is that the feedback somehow affected or caused their level of self-esteem. So let's go back to this. So let's see, I have this, and this is the self-esteem from high to low. And then I have two groups, positive feedback and negative feedback. All right. And what I might do is measure them. And on average, the 5 people who receive positive feedback, their self-esteem is up here. And the people who receive negative feedback, their self-esteem might be a little bit lower. Do you see how these two groups are different? They're different from one another. Now, I know that I used random assignments, so the people in these groups most likely are similar to one another. So what I can conclude is that the thing that must have affected their self-esteem was whether or not they received positive or negative feedback. Okay? And this is how a true experiment works. Now, the key to an experiment is that you have two groups that are similar to one another. And so you have to make sure that you use random assignment, because that allows me to assume that the two groups are similar on lots of different issues. So if we're looking at intellect, personality, age, they're all going to be similar. Now, let's say I wanted to do an experiment. So there are examples of good random assignment and bad random assignment. If you let the students choose their group, it is bad random assignment. You have to do it, and you have to make the two groups up randomly. So an example of good random assignment is to create slips of paper with a 1 or 2. Students pick the slips of paper out of their hat. Okay, that's random and lucky, and they either get a group A or a group B. And you have two groups that are similar. If, on the other hand, I decided to compare males with females, that's not good random assignment, because we don't know. Males and females are different. Actually, I will tell you they are different. It turns out that as a general rule, men tend to report more self-esteem than do females. Okay, so the two groups are not equivalent at time one. So I can't conclude that my feedback affected their self-esteem. Okay, so what I want you to know is that in experiments, we have to use this thing called random assignment. On your test, what I'm going to do is I'm going to give you some examples of assignment strategies. Some of them will be random and some will be non-random. And I'm going to want you to be able to tell me which assignment strategies are random. If you want, next week, we can even go in webinar, we can even go over some of these different assignment strategies if you want to get an example of how you can do that. But that's the key to an experiment. All right. Now, sometimes we can't do an experiment because it's unethical. Actually, let me give you an example of a study maybe you couldn't do. Did you know that there has never been an experiment to prove that smoking causes lung cancer? There's never been an experiment to prove that smoking causes lung cancer. Okay? Let me give you an example of how I could do an experiment to prove that smoking causes lung cancer. Let's say I go into a 3rd grade class and I have a hat full of A's and B's, and I have my students pick a letter out of the hat, right? And so what I'm going to do is I'm going to tell those 3rd graders, I'm going to teach the 3rd graders who select A's, I'm going to teach them how to smoke cigarettes. And every day I'm going to give those 3rd graders cigarettes, all right? On the other hand, the B's, I'm not going to teach them to smoke cigarettes. And in fact, I might even give them an anti-smoking lecture, right? And so now I have randomly created two groups of 3rd graders, one group that smokes cigarettes and one group that doesn't, right? And I'll measure these students over the rest of their life to see who develops lung cancer. And I might find that the kids in group A who smoked developed lung cancer, and those 3rd graders that I didn't teach to smoke don't develop lung cancer. That is a perfect example of an experimental study to demonstrate that smoking causes lung cancer. However, can any of you tell me what would be the problem with that particular experiment? What's my problem? Hmm? I'll go ahead and you can type that in the chat bar as I talk about the correlation. Now, the correlation is a way of comparing two groups that doesn't involve random assignment. And so most of the research showing that smoking causes cancer is done with correlational studies. In a correlational study, you just measure two pre-existing variables in people and see if there is a linear relationship between these two variables. An example of this might be IQ and academic achievement. So you know what? There is a strong positive correlation between IQ and academic achievement. If you look at that far square over here on the left side where it says positive correlation, okay, on the y-axis, we would have your grade point average, your GPA, and on the x-axis going along the bottom, we would have your IQ score. And what you're going to find, especially in elementary and junior high, you're going to find that the students that have higher IQ scores tend to make better grades. And you see how the scores have this linear direction where you can see these X's. These X's are each of the participants. And what you can see is that each student, as their IQ gets higher, their GPA gets higher. That's an example of a positive correlation. Now, there are also examples of negative correlation. And a negative correlation is that when one variable goes up, the other variable goes down, right? So you know what? I might measure your alcohol usage and your GPA. So I'll have each one of you fill out a survey where you tell me how much alcohol you drink every week. And I'll also ask you to tell me your GPA. Now, I'm not making you drink. I'm not making you not drink. I'm simply measuring these two behaviors that you do. And so on the y-axis, we would have the number of alcoholic drinks you have a week. And then on the x-axis, we would have, on the y-axis, we would have your GPA. And on the x-axis, we would have how many alcoholic drinks you have a week. And what you'll notice, the more alcoholic drinks you have, the more your alcohol consumption goes up, the lower your GPA is. So do you see how as one variable goes up, the other variable goes down? This is what's known as a negative correlation, okay? Now, we could measure two variables and find out that there is no relationship. So I can measure the number of shirts you have in your closet and your GPA, okay? GPA would be on your y-axis, and the number of t-shirts you have in your closet would be on the x-axis. And what I would probably find was that there appears to be no linear relationship between the number of t-shirts you have and your grade, your GPA at Wake Tech. And so do you see how the third box here on this over here, this third box doesn't seem to show a line going up or a line going down. This is what we would call a zero correlation, okay? Now correlations are actually measured. Correlation statistics go from -1 to 1. Okay, there you can actually do a statistical test, and it'll give you a correlational statistic. So a correlation of -0.70 is a strong negative correlation. A correlation of 0.45 equals a strong positive correlation. And 0 equals no correlation. Now, I don't know if you know this, but IQ and IQ and academic performance equals about 0.7. There is a strong positive correlation between your IQ and your academic performance. So you can do a correlation and demonstrate mathematically if there is a relationship between two variables. Now, the advantage of the correlational method is that you can do studies that are unethical, that you can do studies that couldn't be ethically done as an experiment. So I can't make people smoke, but you know what I can do? I can ask you how many cigarettes you smoke a day, and then I can measure whether or not you get lung cancer later in life. I'm not doing anything, I'm just measuring an existing variable. So correlations allow us to do research studies where it's unethical or impossible to create an independent variable and use random assignment. The disadvantage, though, is that you can't prove that one variable causes another, okay? So here's the deal. People who smoke more tend to get lung cancer. Now, does the smoking cause the lung cancer? Or, and this is kind of ridiculous, but it is possible, do you think some people might be born with a teeny tiny tumor in their lung, and that tumor might make that person want to smoke cigarettes? You know, like when you get an itch, you try to scratch it? Crazily enough, maybe lung cancer causes people to want to smoke. What? Or there might be a third variable problem. Maybe it's not smoking that causes lung cancer, but it's alcohol consumption. And maybe people who smoke a lot of cigarettes also tend to drink a lot of beer. So it's hard to use a correlation to say that A causes B, but it does allow us to show that there is a relationship between two variables. Okay? Now, over the course of this semester, we're going to be talking about case studies, correlations, and experiments. And all of these represent ways of gathering data to test our hypotheses that we've developed. Okay? And so over the course of the semester, anytime we talk about a research study, you should be thinking about what the strengths and advantages of that particular research method happen to be. Okay, now that's all I had to say today. Does anybody have any questions before we end the broadcast? I'd like to thank everybody for coming. We've had a maximum of 11 students at one time, and we've had 9 students almost the whole class. I really appreciate you coming today. Anybody have any questions? Anybody want to share anything? Any examples? I'm going to give you a second to type in the chat bar, and I'm going to tell you that your discussion boards are due tonight by 11:59 p.m. Your homework is due Friday night, tomorrow night by 11:59 p.m. And if you have any questions, you can send me a text or an email, and I will get back to you just as soon as possible. All right, I don't see that we have any questions, so I'm going to go ahead and close this class out. You folks have a great day. It was good to see you, and I hope to see you next week for class, okay? Take care. Bye.